Now we are trying to discuss the capacitor related problems for our understanding and better concept building. So what I would like to tell you, in the final discussion of capacitor, we already know that here is the capacitor, and between the plates of the capacitor air is there, and A is the plate area and D is the separation between the plates. So what will be the capacitance? We have already seen capacitance C is equals to epsilon naught A by D. Epsilon naught is the permittivity of free space. Now the same capacitor is filled with some dielectric. In between the plates the dielectric is filled, the distance remains the same D, and plate area remains the same A. In this situation, C is equals to, in this situation the capacitance of the same parallel plate capacitor will be epsilon naught K A by D. So this we already know, this we already understand, that this is the capacitor with air between the plates, has the capacitance epsilon naught A by D, and this is the capacitance of the same capacitor when the space between the two plates is filled with dielectric having dielectric constant K. So this thing we already know. Now next thing what I would like to tell you, suppose a situation is there in this way. The same capacitor is there, plus Q minus Q, but this time the distance remains the same D, but this time it is filled with K1. This distance is your D by 2, and this distance is again your D by 2. This is K2. Here it is filled with K1 and it is filled with K2. Plate area remains the same. Now what is the capacitance? This is the first problem that I would like to discuss in this series, in this final series. So now what will be the capacitance? Here you can understand very carefully that this capacitor is basically combination of two capacitors. This capacitor is basically combination of two capacitors. See, one capacitor is this with K1 dielectric, and one capacitor is this with K2 dielectric. This I am taking as C1, this I am taking as C2, two capacitors are there. This plate separation is your D by 2, this plate separation is your D by 2. Now the two capacitors are in series connection, so equivalent capacitance C equivalent is equals to C1 series. In series what we get? C1 into C2 by C1 plus C2. Now try to understand what will be the value of C1. If we try to see, C1 is equals to epsilon naught K1, area remains the same A by distance between the plates D by 2. So it is your 2 epsilon naught K1 A by D. This is C1. What is C2? C2 similarly we can write epsilon naught K2 A by D by 2. So this is giving you 2 epsilon naught K2 A by D. So we have got C1 and C2. So what can we do? We can do in this way. Now only we will have to put the value and get the result. And if we are able to get the result, the problem is solved. So what is our result now? So C equivalent capacitance means what? If these two capacitors are replaced by a single capacitor, then that capacitor will do the same work. This is the single capacitor. It will do the same work as it is done by these two capacitors. So see carefully. So C equivalent is equals to C1 C2 2 epsilon naught K1 A by D into 2 epsilon naught K2 A by D by C1 C2 C1 plus C2 epsilon naught K2 A by 2 D plus 2 epsilon naught K1 A by D. We are getting in this way. So the final conclusion is in this way. Here we can take 2 epsilon naught K1 K2 K2 2 epsilon naught I am making a square because it is 2 times. A I am making a square by D I am making a square. Here we can take 2 epsilon naught A by D in bracket, it will be K1 plus K2. So this D will cancel, 2 epsilon naught a square will cancel, A with a square will cancel. So what is our result? Our result in this way we are very near to our result, and that result is here C equivalent is equals to epsilon naught A by D 2 K1 K2 by K1 plus K2. This is the expression for your C equivalent. And this factor is basically K equivalent, that is equals to 2 K1 K2 by K1 plus K2. We can write in this way. If there are two dielectric, then we can write in this way that equivalent dielectric 2 by K equivalent is equals to 1 by K1 plus 1 by K2. This is the thing that had to be understood very carefully. So this is the K equivalent value that we are getting. Now this can be replaced. This is symmetrically placed. That symmetrically placed means what? Half is this and half is this. Half portion is filled with the dielectric having dielectric constant K1, and another half is filled with dielectric having dielectric constant K2. So this thing we have understood. Now the next thing is there, that if suppose in the parallel plate capacitor, not 2, 3, if we take that in the parallel plate capacitor, in this example only I will tell you here that in the parallel plate capacitor there are 3 regions symmetrically placed. That means this is D by 3, this is K1, this is D by 3, this is K2, and this is D by 3, this is K3, here, here. This is the capacitor. Plate area remains the same. Here the plus Q charge is there, here the minus Q charge is there. So in this case there were 2 dielectric, and here there are 3 dielectrics. So here we will first find the K equivalent by this same. Here 2 dielectric is there, so 2 is there. If 3 dielectric is there, we will use here 3. If 4 dielectric is there, we will use here 4. So we can find here 3 by K equivalent is equals to 1 by K1 plus 1 by K2 plus 1 by K3. This is giving you K2 K3 plus K1 K3 plus K1 K2 by K1 into K2 into K3. This is, so K equivalent is what? K equivalent is 3 K1 K2 K3 by K2 K3 plus K1 K3 plus K1 K2. So this is the K equivalent we have found. Now what will be the capacitance? C equivalent? C equivalent we can get by the same formula, epsilon naught A by D. So therefore C equivalent is equals to epsilon naught A K equivalent by D. At the place of K equivalent you get it, and this will be your answer. So this is the way we can apply the concept of dielectric in the capacitors, and we have solved this one problem, which is very important for your examination point of view. Now let us discuss the other example. Other example we can understand of same profile. We are trying to understand the other example. Second example I am taking in this way, that suppose again the parallel plate capacitor is there. This is your parallel plate capacitor, plus Q minus Q. Plate separation is D, same, and plate area is A, but this time it is filled symmetrically with dielectric K1 and dielectric K2, this region. So here area becomes A by 2, here area becomes A by 2, D remains the same. Again there are 2 capacitors, here again there are 2 capacitors, but see how we can understand it. Yes, here is the capacitor, here is the capacitor, this is point A, this is point A, this point is A, this point is B, this is your B. This is C1 capacitor, plate separation remains the D and area becomes A by 2. This is C2 capacitor, plate separation remains the D and area A by 2. Now what is C equivalent? These are in parallel, so C equivalent in parallel, what will happen? C1 plus C2. C1 is what? Epsilon naught A by 2. Why A by 2? Area has become half. A by 2 surface area has become half. Epsilon naught A by 2 K1 by D plus epsilon naught A by 2 K2 by D. So what we are getting? We are getting epsilon naught A by D K1 plus K2 by 2. And what is this? This is your arithmetic mean. So here this is the equivalent capacitance, and K equivalent is what? K equivalent is your K1 plus K2 by 2, that is arithmetic mean. So in this way we can find the capacitance of the parallel plate capacitor in the two cases. These two cases understanding will help you in clarifying the concept regarding capacitor filled with dielectric, capacitor filled with dielectric. Now next thing that I would like to share, that I would like to discuss with you people is that I am trying to give you a situation, understand this situation and try to give me the answer, because in your examination there are certain times when the questions are repeated, but sometimes a new question is being framed on the concept that is already discussed in your syllabus. So to prepare that type of new framed questions, I am trying to give you this question. Try to give the answer. See, all of you know that here is the parallel plate capacitor and its distance is d, plate area is A, and capacitance C is equals to epsilon naught A by D. If I fill a dielectric D, then it is epsilon naught A K by D. This is the capacitance of the parallel plate capacitor. Now I am modifying from the same concept, I am modifying this concept by a new question. My problem is there. So third question I am asking. Here is the parallel plate capacitor. Plate area remains the same. Distance also remains the same, D. But this time at a distance x from one plate, this distance is your x from one plate, I am putting a dielectric slab of dielectric constant K, and the thickness of the slab is your T. You have to tell me, so this distance will be D minus T minus x. This distance is this. Now you have to tell me the capacitance of this capacitor. Find the capacitance of this system. This is the question. Parallel plate capacitor you have seen, we have already discussed. Distance between the space filled with capacitor, then also we have seen. If the space is filled with different capacitors, that also we have seen. And if it is partially filled with a dielectric of dielectric constant K, plate area remains the same, distance remains the D, then what will be the capacitance of this capacitor? That is my question. Find the capacitance of the system. This I would like to discuss right now. If this situation is given to you, you are seeing that here are three regions, region 1, region 2 and region 3. There are three regions. Here I am giving the name of the surface 1, 2, 3, 4. In the process of discussion, in the process of finding the capacitance of the parallel plate capacitor, here the charge plus Q is given and here the charge minus Q. So first step to give the charge we have given. Then second step to find the electric field. So now we will try to find the electric field. There are three regions, so we will find the electric field in three regions. So in region 1, E1 is equals to, what is the value of electric field? electric field is basically sigma by epsilon naught. So here sigma means Q by A epsilon naught. This is the electric field. In region 2, electric field E2 Q by A epsilon naught K. And in region 3, what is the electric field? E3 Q by A epsilon naught, because here also again air is there. Now see, so first step to give the charge, second step for finding the capacitance is to find the electric field, third step potential difference. So potential difference, we know potential difference delta V is equals to E into D. This is the formula. This is the formula as electric field is constant. So see, so delta V E1 into X, E1 into X plus E2 into what? T plus E3 into what? D minus T minus X, D minus T minus X. We have got, this is delta V. Put the value. Delta V is equals to, E1 is how much? Q by A epsilon naught into X plus Q by A epsilon naught K into T plus Q by A epsilon naught D minus T minus X. We have got this. Now what I would like to do, I would take common. So if I am taking Q by A epsilon naught as common, X plus T plus D minus something is missing, T by K, D minus T minus X. So this X will cancel. So what we are getting? So we are getting, therefore potential difference delta V is equals to Q by epsilon naught A D minus T plus T by K, D minus T plus T. Now third step, we have calculated the potential difference. Now what is our next step? In next step, for finding the capacitance, we have to use the formula capacitance C is equals to Q by V. So therefore capacitance C is equals to Q by delta V, that is your epsilon naught A D minus T plus T by K. See, this is the expression for your capacitance of the parallel plate capacitor with dielectric of thickness 3 T inserted between the plates. What is important here to understand, this X term is not here. So this X has no meaning at all for this one. So it is independent of location of dielectric between the plates. So this is the expression that we have got. Now next thing is there to understand. What is main thing you have to understand? It is not essential that always you will be getting one dielectric. Position is no matter, whether this dielectric is here or here or here or here, wherever it is there, no matter. The expression will remain same for capacitance. But if in case, if there are more than one dielectric, so there is a method by which you can remember this thing. In a very simple way, you can remember this thing. There is a method, and what is that method? That method is basically that method is basically in this way. Here you see. Method is that C is equals to epsilon naught A by whatever is the separation, that is D, minus thickness of dielectric T, plus filled the thickness with dielectric, that is plus T by K, minus thickness of dielectric plus filled that thickness with dielectric constant K. Now if there are a number of this type of slabs, then how I will write? If there are a number of slabs, then we can write C is equals to epsilon naught A by D. If T1 is there, minus T1 plus T1 by K1. If other dielectric is there, then minus T2 plus T2 by K2. Two dielectrics. If there are a number, you can continue it, and this will be giving you the capacitance of the parallel plate capacitor with so many dielectrics. So this thing you should understand. It is very helpful to remember this formula. And whatever is the dielectric, remember method. How to remember it? Epsilon naught A by D minus thickness of dielectric plus thickness filled with dielectric, minus thickness of dielectric plus thickness filled with dielectric, minus thickness of second dielectric plus thickness filled with second dielectric. Like that only you can remember. So this is the way we have understood this concept also. Now few questions we have discussed, that is for your examination point of view, it is quite helpful. It will help you in building up the concept. Clarity of concept will be there. When clarity of concept is there, expression will be better. When expression is there, confidence will develop and chances of doing mistake will be minimum. So you can face the examination carefully and confidently in a very good way. So this thing we have understood. Now I would like to discuss few simple questions. Here is the capacitor. Here is the capacitor. Then here is the capacitor. This point is B. This point is A. All this point is A. This point is B. C, 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 and find all capacitance are equal. Find equivalent capacitance between A and B. This is the question. Find the equivalent capacitance between A and B. This is the question. Now, how to do it? you understand it that this two are in series, this two are in series. So in series what will happen? In series, if two equal capacitors are there, the equivalent capacitance is C by 2. So this will give you in this way. Here this point is A, here and here you are getting C by 2. This point is your B. This becomes C by 2. C, C, C. Now these two are in series, so C by 2. Again here these two are in parallel, so what will be equivalent capacitance? Parallel C plus C by 2, that is 3C by 2. So I am replacing this diagram with here now here you see this is replaced by 3C by 2. So it is your B, it is your A, 3C by 2, C, C. Again these two are in series, so what will be equivalent capacitance? C equivalent in this case will be C into 3C by 2 by C plus 3C by 2. That is giving you 3 by 2 C square into 5. 5C into 2. 2 will cancel, C square 3 by 5C. So this can be replaced by 3 by 5C. So we are getting this value and this value, and what will be here? This is 3 by 5C and this is C. This is A, this is B. So what is our result? Now these two are in parallel. So C equivalent is equals to C plus 3 by 5C, that is 8C by 5, that is 1.6C should be your answer. Here we have done the mistake. So this is the one example based on the equivalent capacitance. Now we have to move to the next example. How? Let us move. First note it down very carefully. Now see it carefully. This is your arrangement of capacitor, and find the charge on the right plate on this Q is equals to how much, that you have to find. How to find? Here minus Q is there. So if this is minus Q, here will be plus 20 microfarad, minus plus. Now you see, now what is important to understand, this plus, this is isolated section, so net charge should be 0. This is isolated section, so net charge should be 0. So here it will be minus Q1 minus Q2 because plus is there, and here it will be plus Q and like that only, plus will be there. Now if we are able to find minus Q, then this will be plus Q. This is isolated, so plus 2. What I would like to tell you, see that here capacitance is different, so charge is different, and charge are in the ratio of capacitance. So Q1 minus Q1 is is equals to 3 by 7, 3 plus 4 into 20, that is 60 by 7, that is 8.5 microcoulomb. This minus Q1 is 8.57 microcoulomb. So what will be on the right plate? So Q will be plus 8.57 microcoulomb. This should be your answer. See, here minus, so here plus. In this section, isolated section, net side should be 0, so plus. So in this two, minus 20 should be there. So Q1 charge is in the ratio of their capacitance. So Q1 is equals to what? Q1 is equals to capacitance by total into total charge. Total charge is how much? This, and we are getting 8.57. So with these few questions, I am ending the session. Hope you will enjoy this series of discussion of the questions, and you will continue. This will be beneficial for you only if you are able to continue the practice. Capacitance section is over. Complete capacitance section is over. If you will practice this much amount of problem and you will get confidence over these matters, then undoubtedly your exam will be trouble-free, tension-free. You will enjoy in appearing the exams.